Good morning, everyone. Thanks for joining me today. Our work that will be shared today, titled with Effects of Visual Prompt and Human-Machine Interface for Reconstruction Teleoperation System. Before diving into the details of this study, I'd like to share the overview of this work. In remote teleoperation context, the operators remotely communicate with heavy machinery. In this context, limited visibility can degrade their spatial awareness, resulting in false manipulation. Based on spatial awareness is based on the spatial data, our research started from the question of how can we effectively map those spatial data for teleoperators to enhance their awareness of surrounding environments. Humans can generate their own attention in two different ways. First, as a top-down approach, when the task is given, they can generate their attention based on their goal tailored to the task. On the other hand, as a bottom-up approach, the visual saliency can guide their attention, and the visual prompt utilizes this concept. As visual prompt utilizes visual saliency to design the intuitive representation of visual prompt, design the visual prompt aligns with their task is important, and that is what we wanted to investigate in this study under the context of work environment and their task. There are challenging environments in construction sites, such as demolition site, and after disaster occurs, it limits human access physically because it is hazardous sites for them. Still, there are tasks requires continuous human cognitive engagement, meaning that it is hard to be fully automatized. To deal with this problem, current practices has adopted teleoperation to placing operators in a safe place, remotely communicate with heavy machinery with distance. Still, statistics shows us that there's a problems of lower productivity and higher risks of safety hazards in teleoperation compared to that of manual direct manipulation. And also, teleoperators can face additional challenges on their awareness of surrounding environments from its characteristics of remote communication. Interface holds a crucial role in here because this is the only method that teleoperators can be provided with and be assisted with. Especially our vision is the dominant human sense, which captures up to 70% of our waking attention, meaning that visual interface holds the tremendous potential and utilize it to generate their spatial awareness. Based on Hirakawa's 4 stages of action, from the visual information provided in visual interface, humans perceive the target, and based on that, they generate their own understanding of it. And from these understanding, they plan their operation and execute it as a command, resulting in the final interaction with heavy machinery. Still, the key is the communication between the heavy machinery and the operator. However, this is not only the factors in the teleoperation system. There is a need to understand as a holistic view by integrating with the considerations of the work environment and their task to understand how human-machine interface can affect teleoperators. There are a body of literature to deal with this problem to alleviate the teleoperators problem they might face with. Previous studies has investigated to provide multiple viewpoints to enhance their visibility. From the concerns of these additional viewpoints might distract teleoperators, the visual prompt has been designed to guide their attention, and also previous studies have demonstrated the potential of it by augmenting the distance-related data to effectively provide the spatial data to teleoperators. However, the knowledge that would like to address within this study is as the visual prompt utilizes the principle of the visual saliency, these effects can be highly affected by the surrounding environments. And that is what we wanted to investigate within this study. And what motivates us to start this research is the right side of the studies. These studies, investigations of by varying the level of visual cues in the surrounding environments, those environment itself affects human depth perception. as manipulating heavy machinery requires a delicate depth perception. Related to this references, we started this study. To alleviate the depth ambiguity that the teleoperators might face with, and from the needs for insight how different types of visual prompts can affect their teleoperation performance and their experience for teleoperators. Our research is designed to answer the questions of how can we effectively map the spatial data to enhance their spatial awareness, and how this effect can be varied by their work environment settings, their task. To evaluate the impact of visual prompt, virtual environment is modeled in our experiment, and the target area was demolition sites as a representative case where teleoperation is adopted. And debris removal task was the target task designed for this experiment, consisting of the sequential tasks from picking up debris, avoiding obstacles, and releasing the debris in the dumpster area. As you can see, there is two different representation types is provided. One is the discrete representation of conveying the data for spatial data, and the other one is the continuous one. The details of the visual prompt will be provided in the future slide as well. To add the physical interactions to the model to replicate the real-world task settings, some of the modules are designed in the modeling phase. First is the debris control module to control the debris to replicate their physical interactions in real-world settings. We control the debris after picking up the debris before releasing it by tracking the angle of the body part of excavator. And also in case of collision occurs, sudden dust effect and also the metal hitting sound let teleoperators being aware of they are in collision status immediately. And along the experiment, 3 measures of performance was captured from the amount of the debris dumped and their completion time and collision. Those measures are comprehensively evaluate their performance. To provide you a little more details on the visual prompt, with the obstacle avoidance context, with the discrete representation of proximity is divided into 2 granularity level. The warning danger is based on the proximity, and this is provided to the participants prior to the experiment. And also the continuous representation with 4 decimal values keep changing and keep tracking of their proximity at the current phase. For the work facilitation visual prompt, the visual prompt setting stays the same with the 2 levels of granularity, close, very close, and also continuous representation where decimal values of proximity is provided. To evaluate the impact of different representation of visual prompt under the construction context, we additionally designed the comparison model as a baseline as a extending 3D Fitzler task, which is one of the representative tasks to evaluate their depth perception in human-computer interface domain. As you can see, this just requires the depth perception, and based on those depth perception, it is required to move 1 cube to the destination. With much simpler task settings, the visual prompt is designed with the same principle, following the debris removal task as well. The experiment was conducted with 33 participants, and all they are pre-screened with their industrial experience for only who has an industrial experience to assume that they have some sort of knowledge on the priority of productivity and safety concerns in construction domain. And within the task, 3 settings of non-visual prompt as a baseline and with the discrete and continuous visual prompt has been provided for both of debris removal task and extending 3D Fitzler task, and all their order is randomly distributed. And also the task performance for the extending 3D Fitzler task, aligning with the performance metrics with the debris removal task, consumed time and their number of false movements has been tracked to evaluate their quality of their work. And along with those task performance, subjective experience ratings, and their eye data has been collected together. I'd like to share you some highlights of the findings within this study. First, in the baseline, the extending 3D Fitzler test, which requires lower level of cognitive and physical demands of the work with their environment with lower complexity. There is no non-significant performance enhancement when the visual prompt is provided, regardless of their visual representation, meaning that in lower complexity scenarios, those augmented visual prompt does not significantly enhance their performance, while their perceived level of difficulty significantly eased with those augmented visual features. Comparing with this, interestingly, in demolition sites, with their higher cognitive demands required, those visual prompt has significantly reduced the performance regardless of their visual representation. And one of additional interesting finding was focusing on the metrics on the number of collision occurrences, compare the two settings with the discrete and continuous one. The discrete representation shows a significant collision reduction effect, meaning that there is an intuitive representation tailored to their task. This aligns with the backup interviews with the participants as with the obstacle avoidance context when the representation of spatial data is represented with the discrete granularity. This can guide their attention effectively compared with the continuous changing values because they are kept distracting with tracking those changes. Also, to triangulate the one with the eye tracking data, the three bottom figures representing one single participant's eye movement. With the non-visual prompt setting, the very left, they scan their environments by rotating their excavator machinery in obstacle avoidance context. And compared to those to the left, the middle and right one, their eye gaze durated on the visual prompt, attracting by the visual saliency. The size of the circle represents their duration time. And for the 33 participants on the very right top figure, it shows that both representation of visual prompt effectively guide teleoperators' attention with the significant reduced environment scanning time, illustrating that its effectiveness of guiding attention of teleoperators in teleoperation context. I would like to finalize this presentation with highlighting some of the key findings and the broader implications of this study. The result of this study demonstrates there is a divergent effect of visual prompt, and this effect can be varied by their task settings and work environment context. And their intuitive representation of visual prompt is highly affected by their work context, meaning that customized design is essential to provide essential representation of visual prompt. And also our study demonstrates its potential to capture teleoperators' attention required to their need. And also one of our ongoing work is to convey this spatial data effectively with additional sensory channel for those of limited visibility and when teleoperators' attention is captured with another task. On top of that, the broader implications of this study could enhance the human-robot interaction by actively guiding teleoperators' attention with reducing the involuntary attention shift. And also how to support teleoperators to exploit fully their potential of visual information before integrating the other sensory channel is the broader implications of the study. I would like to wrap up this. This comes to an end of the presentation. Thank you very much for your attention.